Okay, so this is the first example I'm going to take, and I'm just going to break these up into small little bits, and then the practice questions, you guys can try some of those by yourselves, okay? So the first example, I've just got one line, and it's a straight line, okay? So if I remember from back up here, I remember a straight line that comes up. That's accelerated motion, okay? That one is accelerated motion. So I'm going back down here, and it says describe the motion of the object. So just be a little bit careful when you're describing. First thing is, you should be using the words that are on the axis. So the last time we were looking at distance time graphs, and this is where students often get mixed up and confused with this. Now we're looking at speed time graphs, okay? So it means I should be including the word speed, and I should be including a time. Okay, so the first thing is I need to tell somebody who's drawing this graph, I need to be able to describe it in such a way as my description could be used to draw the graph. Okay, so if I was going to draw the graph, I would have to tell somebody to start at 0. So we should start, the object starts from, you could say 0, but we tend to say rest, okay, in physics, we tend to say rest. It then accelerates at a constant rate, or a constant acceleration. We know it's constant because that's a straight line. Okay, that's a straight line like that. So it then accelerates at a constant rate to a speed of 8 meters per second. Don't forget your units. Over a time of 10 seconds. Okay, so that's the first thing, description done. Okay, second thing we're going to try to do is we're going to try to use the formula to calculate the acceleration. Okay, so just to remind you of what the formula looks like, the formula looks like this. So we've got acceleration is equal to the final velocity v minus the initial velocity u divided by the time taken. Okay, so what we have to do now is we have to locate those initial and final velocities on our graph. So we can see here that we're starting from 0, so that would be our u. Okay, that would be the initial velocity. The second thing to do is to look at the final velocity, and that's the speed that we get at the end. So there's my v there. And remember, my velocity axis or my speed axis is along here. So I'm going to be taking my readings off of the y-axis or the speed axis. Okay, so I'm just going to make a list. So v is equal to 8 meters per second. So if you follow that back to the speed axis, u is equal to 0 meters per second. So it's down here, again on the speed axis. Then we look at the change in time, or the time taken for that accelerated motion. Well, it was accelerating for a whole 10 seconds. So now I can just substitute my numbers into my equation, and I get 8 meters per second minus 0 meters per second divided by 10 seconds. Now if I follow what happens in the units with that, I wind up with an acceleration of 0.8 meters. You see there's a second here and there's a second here, and they're both underneath the line, meters per second squared. Okay, so my acceleration should be 0.8 meters per second squared. That's how you do it using the formula.